Hello, my name is Jesus Dominguez and I'm an HDR UK researcher in clinical trial informatics. In a previous video entitled The Benefits and Considerations of Represented Clinical Guidelines as Computable Guidelines, I discussed the limitations of clinical guidelines and the efforts that are made to convert them into computable guidelines that are directly executable by clinical decision support systems. In this video, I will briefly discuss some of the major challenges faced in the adoption of guideline-based clinical decision support systems in clinical settings. In particular, I will analyze the technical and organizational barriers that need to be overcome in order for health information systems to interact in a meaningful way. But before I do, let me remind you of two basic facts. Clinical decision support systems are computer applications that can provide clinicians and patients with clinical knowledge and patient-related information presented at appropriate times to assist in making clinical decisions. Information encapsulated in clinical guidelines is an undeniable source of knowledge that can be employed to enforce the use of clinical decision support systems in real clinical settings. So, what are the challenges faced in the adoption of guideline-based clinical decision support systems in clinical settings? Let's start with the oldest problem, which has been around since the 90s with the advent of ardent syntax, one of the first modern languages used for representing and sharing computable guidelines. This is the interoperability problem, or how to make the decision support layer talk to the electronic health record in a meaningful way. In ardent syntax, this is commonly referred to as the curly braces problem, as a reference to the braces used in the language to refer to external clinical data items. These data items are generally understood to be from the electronic health record. So, more generally, we define interoperability between two or more systems as the ability to exchange information and then make use of that exchange information. Historically, the problem is that all electronic health record systems are different from each other, and some of them do not even expose anything like a standard interface to interact with external systems. Clearly, if computable guidelines cannot be executed using patient-relevant clinical data, the entire endeavor of adopting guideline-based decision support systems in clinical practices will remain ineffectual from the start. We can identify 4 levels of interoperability among health information systems. The lowest level is associated with communication protocols and the infrastructure needed for those protocols to operate, enabling machine-to-machine communication. The next level up is about achieving syntactic interoperability. How can a clinical decision support system exchange and manipulate data from electronic health records? The answer is by understanding the format and structure of the data exchange. In our team, we work with fast healthcare interoperability resources, commonly known as FHIR, by Health Level 7 International, and with Open Electronic Health Records, or Open EHR, both free and open source emerging global standards that facilitate the capture and share of clinical data across heterogeneous health information systems. FHIR uses a unified structure for describing clinical data elements and a retrieval mechanism. OpenEHR uses a unified information model to describe the electronic health record. The next level is for semantic interoperability, which is about enriching the exchange data with context and meaning that is shared among all engaged systems. Semantic interoperability is a requirement for clinical decision support systems to enable the application of their embedded techniques and methodologies, like computational logic, knowledge discovery, or machine learning, for instance. Semantic interoperability is the domain of medical terminologies, nomenclatures, and ontologies, like SNOMED-CT, which stands for Systematized Nomenclature of Medicine Clinical Terms, and includes clinical findings, procedures, substances, and organisms, among others. And LOINC, which stands for Logical Observation Identifiers, Names and Codes, and is a database and universal standard for identifying medical laboratory observations. The use of these terminologies, combined with syntactic standards like those previously discussed, can ensure that healthcare data have a clear structure and unambiguous semantics among systems where data is shared. At the highest level, interoperability also involves organizations and the legislations and policies that govern and incentivize